sixth grade. It's Mrs. Roselle. So we just finished our electricity part of our chapter in science on electricity and magnetism. And last year I thought it'd be really great to invite a special guest to come and share some real life knowledge about electricity in the home. Well, obviously we can't do that in person, but I thought I'd still let you introduce you to a special guest. This is my dad. Do we look alike? Anyway, he's going to kind of introduce himself, and we're going to just kind of show a demonstration. Well, not me. He's going to show a demonstration, and I might ask some questions along the way about electricity in the home and some real life things that might come up when it comes to electricity. So why don't you introduce yourself?
Okay. My name is Mrs. Roselle's father. Actually, my name is Chuck, and you can refer to me as Chuck or Mrs. Roselle's father, and that's perfectly fine. Okay, today we're going to use a bit of knowledge that we have about electricity and about what you have learned about electricity to do home repairs. Okay, and so I think we all have occasions where we like to do a little DIY, do it yourself, rather than having somebody else come in and fix things and you get things done quicker. But it's also it's being a good steward of your time and of your knowledge, and the Lord wants us to do that. So that's very important. Today, well, I ran across, I was doing some cleaning up, and I ran across a nice lamp. Okay, and this is just a simple lamp, just a little table lamp, and it's pretty, and it's not chipped up or anything, and it looks pretty nice. And I said, you know, my wife loves to read, and so what I'm going to do is I'm going to make this into a nice little reading lamp for her. But before I want to give it to her, what I want to make sure that it works right. Okay, so we're going to test it. Okay, we all know what this is, right?
It's
Okay.
a plug.
It's a plug. Okay, so I got a plug right here, and I'm going to plug it right on in. Okay. Okay, and here's the switch, and okay, let me try that again. It's not working. Okay, is the bulb tight? Yeah, the bulb is tight.
Is it an old bulb?
Well, it doesn't look old.
No, it looks pretty good.
It's so right away. Okay, what we're gonna do, since it's not working, we know that there's something wrong. Okay, so we're gonna unplug it for safety's sake. Okay.
Always unplug.
Always unplug. Okay, so in fact, I'm going to leave it right here so you can see that it's not plugged in. Okay, so now we're going to take this apart. Okay, now we all know what this is. This is a bulb. Okay, well, just because a bulb is in a lamp and it's not working doesn't mean the bulb is bad. It could be something wrong with the lamp. So I have a tester. Okay, and this is a what they call a multimeter. I can test voltage, AC and DC. I can also test conductivity. Okay, and that's the ability of material to pass electricity through.
What are some good conductors that would be good to use?
Okay, most metals are good for conducting electricity, and if you look inside a wire, and if you even look at the end of this plug, you will see the ends are metal, and that's because metal is a good conductor of electricity. Things that are not good are plastic, like the plastic that lines this thing, and that's why with this plugged in and working, I can touch this and not get a shock. But you don't want to touch this when it's plugged in because you'll get a shock from that. Okay. Also, did you know that our bodies have the ability to conduct electricity? Not as well as other things, but I'm gonna change my voltmeter or my multimeter to what they call ohms, and that's the measure of
I'm gonna bring it up a little closer
resistance.
so you can see. Okay.
Okay. Now, when I take these two leads and I put them together, what happens?
You see.
You see the meter?
Go up and down.
You see this line here, and it comes over here. I'll do it again. See? That's because these two ends are touching each other, so the conductivity is very, very good. But our bodies have the ability to conduct electricity also, but not as well. So much. Look at this. Put my thumb on this one, and I put my thumb in this one, and what do we get?
Ooh, the meter goes up.
We see it move a little bit. See, I'll let go, and I'll press it again, and you see it moves just a little bit. So our bodies have the ability to conduct electricity, but not like metal, okay? Again, when we touch the metal, you see it jumps way up, okay? So, I'm gonna have Mrs. Roselle hold this. The bulb has two parts to it. It has the center post and the outside rim, okay? If the bulb is good, this meter will move, okay? So I'm gonna press this, and what do we see?
Oh, the meter moved.
The meter moved, and I let go, and it drops back down. I touch it again, it jumps back up. So that tells me the bulb is good. Okay, so we'll put the bulb aside, and now we got to go deeper into this. Okay? Well, there's a couple of things. Just as this bulb has this end and then this circle part here, that screws into here. And in the bottom, there is a place where the point touches, and then it has the circle. We can test those also, just in the same fashion. So what I will do is I will hook this connector to one of the wires, and then I'll reach inside here. And what do we get? Did it go?
Nothing.
Nothing. Okay. I'll press the center one. Anything?
Nothing.
Nothing. Okay, let's go to the other wire. Okay, we'll go to this one. And I'll touch the middle.
Nothing.
Nothing. And now we'll touch the outside.
Still nothing.
Still nothing.
I think we found our problem.
I think we found a problem. Okay, so we need to go a bit further into this. So I'm just going to shut the meter off so that we don't wear the batteries out in the meter. Okay? And then we're going to go to this. And this is designed, you can screw this top off, and then by feeding some of this wire back, we're able to pull this up and out. So this is all one long wire from this where we plug in all the way to here. And as soon as I look at this, here's where we have a problem.
Let's zoom in on that.
Okay, yes.
Oh, broken.
We have a problem. It's not connected here anymore.
Well, that makes sense.
Okay? So the very first thing we need to do is we need to fix that. So I'm going to get a screwdriver, and I'm going to loosen up the screw where it connects to. And here's some of the broken wires still on here. And I'm going to remove that. Okay? And then, well, remember we were talking about some things do not conduct electricity very well? This plastic around here protects it. So I got to remove some of that plastic in order to connect it properly to this. Okay? So I have a little handy dandy little strippers, what they call wire strippers. Okay? And I'm gonna open this up like this. And I stripped off the end of this. I'm going to strip off just a little bit more.
So you're exposing all of the metal that conducts the electricity inside.
Now this wire is a whole bunch of little bitty wires, and that's how they make it flexible. Okay, so we're going to take this and we're going to twist this, and so that they're all form like one wire. Okay.
That's cool.
Now I'm going to go on here. I'm going to wrap it around this screw, just like that, and then I'm going to tighten it with the screwdriver.
Nice. So would you say that each one of these sides is kind of like a positive and negative side?
Yes.
Cool.
Generally speaking, the center, which is the tip of your light bulb, is your positive. The twist of the screw part, which is the outer shell, which is this part, is the negative. Okay? So, we're going to, there's one thing that you have to remember when you do a repair. Fixing one thing may cause another problem. If you look at this, and I hold this, this hangs funny. Because this one was cut off and it was shorter. So I need to cut this one to make it the same, okay? That is just being wise and understanding how things work, okay?
Could there possibly, if you don't fix it, could you have like a short circuit?
Yes, you could. Also, this could be the first place that it would fail the next time if there was another failure. So, I'm going to take my wire snippers, I'm going to cut off that extra to make them even. And then I'm going to use these strippers again, and I'm going to strip that clean. There again, I exposed, and then I twist these wires together, and we wrap it around the other screw on the other post, which we know because generally the color, if the color of the contact, the color of the screw is brass or gold color, that is positive. That's generally what they'll do. Where negative is generally silver.
That's
Silver
convenient.
color. Yes. And it does help you to diagnose your problem. Okay? So now I get this wrapped around there. Yeah, I'm gonna make this
Gotta
nice
twist
and
it.
tight
Yeah.
again. Okay, there. And okay, there I got it wrapped around. Now I'm going to tighten it down again with the screwdriver.
So now both sides are equal, and then we don't have to worry about a short circuit.
See, now when I hold it, it stands straight up because this wire is the same length as that. So now I'm going to fit this back down. I pull on this wire on the bottom and have it come out of the lamp and see how it draws it in, okay? And draw it in a little bit more, and it sets back down into its socket, okay? So there we are. Now we're going to put the screw cap on. And now it's all together one more time.
Nice.
Okay? So, we've already tested this bulb, so we know this bulb is good. Okay? So we're going to put this bulb in here again. There, nice and snug. Okay? And I'm going to go plug this in. Okay. Well, if we did everything right, it works. Okay?
Nice.
Again, remember what we did. We tested the parts. We tested the bulb. We saw the bulb was good using our ohm tester, which is that tests for conductivity, meaning its ability to pass electricity. Okay, and the bulb worked. Okay, then we went to the lamp and it failed. Okay, that's why we opened the lamp up. We found a problem, a broken wire. We cut it off, the bad part off, stripped it, reattached, went to the other side, shortened it to make it even, and then we tightened that back up, put it all together, and we have a working bulb. Okay, so now we have a good working lamp. Okay, we have another step though. Okay, we're nowadays most of your bulbs they want you to buy, and it's wise to buy because they're cheaper, are the LED. They're not cheaper to buy necessarily, but they're much cheaper to run and to use, and it uses less electricity, which is good for our environment, and ultimately will put money back in our pocket. Okay,
That
so
sounds good.
this bulb here, when I look at it, it says it's 40 watts. Okay, 40 watts of electricity is used to light this bulb, okay? I have some new bulbs, okay? These are LED bulbs, okay? Very clearly, LED. And this says that this is 9 watts. But it says that it equals 60 watts of light
So it's actually less wattage than this bulb, right?
to use.
To use, but it ends up being brighter because it's almost like
It's
it's equal to a stronger light bulb than this.
right. It will produce 50% more light for less than 20% of the energy. So it's a great savings. So we'll pull one of these out, and you notice they look a lot the same, but it's a little
A
different.
little different.
But the same similar shape, and you look at the bottoms, it has the same parts. It has the contact, the positive contact, plus it has the screw negative wrap, okay?
One thing also that you guys can't see on the video, that this is glass,
Yes.
right? But what is this made up of?
This is plastic.
So both of these are good insulators. Okay, obviously we don't want to get electrocuted, but this is much easier to break. You know, if you ever drop a light bulb or something like that, you have to be very careful because there could be glass all over the place. This is much safer as well.
Plus, there's one more benefit, and homeowners like myself, and you someday when you have your own home, that'll be a big concern, is that the lifetime of this bulb is much longer than what this is.
Yeah.
This bulb here will last about 1,000 hours of use. Now 1,000 hours, it seems like an awful lot,
Yeah.
but well, if you talk about if you didn't turn this off and let it run for 24 hours, how many days would that take?
Ooh, you're testing my math abilities. Probably like 40?
40.
There you go.
It would last for 40. If it was a 2,000 hour, it might last for 80 days. Well, if you have to replace a bulb every 80 days, that's
Like a month. Or a month, 2 months, two and a half
two
months.
to 3 months. Yeah, and that seems like an awful lot. But of course, hopefully, you don't leave the lights on all the time.
Yeah.
You shut them off, and so it's much longer. But this one has a lifetime of anywhere from 11 to 13 years.
Well,
11 to 13 years. So this might cost a little bit more, but it runs at about 20% of the cost of this,
so we're talking months versus years.
and this is 5, 6, sometimes 7 times more efficient than this is.
Sounds
Okay.
like a good plan to me.
You take this bulb and you put this one in, and we turn this on. There we are.
Yeah.
And another thing, this bulb doesn't get hot.
Mm.
It might get just slightly warm if it's been running for a long time, but this one, you let this run for just a few minutes, you can't touch this without burning your fingers. So it's safe. It's much safer that way. So now, the last little thing before I can package this up and give it to my lovely wife is I want to make it look better. Okay? So,
Now you made it run better. It's more efficient. But now we want to make it look nice.
and I get a nice new
Lampshade.
lampshade, and I stick that on there, and I put my bulb back in. And once I got it screwed back in, I tested one more time. And there we
There
go.
we go. Well, that's awesome. Thank you so much, Dad, for giving this really real-life demonstration about how we can take what we learn about electricity, apply it to our everyday life, because maybe you have a lamp at home that you really like that you want to fix up. If you have these materials, then you can go ahead and do it yourself, because, I mean, we love doing things ourselves. We've been given abilities by the Lord to do this and our intelligence, and so we should definitely be able to use our abilities to, help out around the house. So thank you.
And be good stewards.
And be good stewards. Yes, we really appreciate that. So thank you, Dad. And hope you guys enjoyed this 6th grade. See you later.